Sorry in advance if my voice sounds a bit off. I'm sick for weeks, and that's actually why I couldn't download any videos. December 19th, 2025. Right now as you watch this, something is passing Earth. Something that doesn't belong here. Moving at 130,000 miles per hour, carving through the darkness of space like a bullet through silk. It came from beyond our solar system, from the vast emptiness between the stars, traveling for billions of years before finally arriving at our doorstep. NASA has mobilized 12 different spacecraft to watch it. The Hubble Space Telescope has turned its gaze away from distant galaxies to focus on this single object. The James Webb Space Telescope, humanity's most powerful instrument, has interrupted its observations to capture its spectrum, and scientists around the world are divided, arguing, some whispering the question that nobody wants to ask out loud. What if it's not natural? What if someone sent it here? They call it 3I/Atlas, the third interstellar object ever detected passing through our solar system. And unlike the first two, this one has scientists genuinely confused, because the more they study it, the stranger it becomes. Its trajectory shouldn't exist. Its behavior defies easy explanation. And one of the world's most respected astrophysicists, a Harvard professor named Avi Loeb, has gone on record saying what others won't, that we cannot rule out the possibility that this object is a probe, an artificial construct, technology from an alien civilization sent here with a purpose we don't yet understand. Most scientists dismiss this idea. They call it a comet, natural, unremarkable. But their confidence is cracking because 3I Atlas keeps doing things that comets shouldn't do. 15 separate anomalies that pile up like evidence at a crime scene. And NASA, despite their public statements, can't fully explain any of them. This is the story of the most controversial object in modern astronomy, a visitor that has divided the scientific community and sparked a debate that goes far beyond mere curiosity. Because if Loeb is right, even partly right, then everything changes. And if he's wrong, if this is just a comet, then we need to understand why it looks so much like something else. The clock is ticking. The object is already moving away, racing back toward the infinite dark from which it came. And we may never get another chance to find out the truth. July 1st, 2025. The Asteroid Terrestrial Impact Last Alert System, ATLAS for short, is a network of telescopes designed to scan the sky for dangerous near-Earth objects, asteroids that might threaten our planet. The telescope in Rio Hurtado, Chile, was conducting its routine sweep when it detected something new, a faint smudge of light moving against the background stars. At first, nobody thought much of it. New near-Earth objects are discovered all the time. The observation was logged and sent to the Minor Planet Center, the international clearinghouse that tracks every rock in the solar system. But within hours, something became clear. This object's trajectory was wrong. Near-Earth objects orbit the sun. They follow elliptical paths, bound by gravity to our star. This thing wasn't following an ellipse. It was following a hyperbola, a path that would carry it through the solar system once and never return. The orbital eccentricity, the mathematical measure of how curved or straight a trajectory is, came back at 6.139. Anything above 1.0 means the object is unbound. This was 6 times past the threshold. It was moving so fast, in such a straight line, that the sun's gravity could barely bend its path. Astronomers started checking archived images. Had anyone seen this object before without realizing it? They found observations from the Zwicky Transient Facility going back to June 14th. Pre-discovery images showing the object had already been in our solar system for weeks, invisible against the dense star fields of the galactic center. And when they traced its path backward, projecting where it had come from, the answer was undeniable. It originated from the direction of Sagittarius, from the heart of the Milky Way galaxy, from interstellar space. The discovery announcement went out on July 2nd. The object was officially designated 3I/Atlas. The I stands for interstellar. The 3 means it's only the third such object ever confirmed. The first was Oumuamua in 2017, the cigar-shaped visitor that baffled scientists with its acceleration away from the sun. The second was 2I/Borisov in 2019, a comet that behaved more predictably. And now this, larger than either of its predecessors, roughly the size of Manhattan, and exhibiting behavior that would spark one of the most heated debates in astronomical history. Initially, scientists weren't sure what they were looking at. Was it an asteroid? A comet? The distinction matters. Asteroids are rocky or metallic, inert, dead. Comets are icy, and when they approach the sun, the ice sublimates into gas, creating a glowing halo called a coma, and often a spectacular tail. On July 2nd, telescopes in Chile, Arizona, and Hawaii all detected a faint coma around 3I/Atlas, a fuzzy halo of gas and dust. The object was active. It was a comet. But a strange one. Most comets develop bright, spectacular tails that stream away from the sun, pushed by solar radiation and the solar wind. 3I/Atlas's tail was weak, barely visible, pointing in an odd direction. And as the comet approached the sun, getting closer and heating up, something weird happened. It started glowing green. Not the pale yellow or white of reflected sunlight, but a vivid electric green that made it stand out in telescope images like a beacon. The green color comes from diatomic carbon, a molecule that forms when carbon-based compounds break apart under ultraviolet radiation. It's not unheard of in comets, but the intensity was unusual, and the color kept changing. As 3I/Atlas moved through the solar system, it shifted from pale to vivid green to almost emerald, as if its surface composition was evolving in real time. Scientists couldn't agree on why. On October 29th, the comet reached perihelion, its closest approach to the sun. At 1.36 astronomical units, about 126 million miles, it passed between the orbits of Earth and Mars, and that's when the real anomalies started piling up. The comet's rotation axis, the invisible pole around which it spins, was aligned in a way that had less than a 1 in 40,000 probability of occurring naturally. Its trajectory was suspiciously close to the ecliptic plane, the flat disk where all the planets orbit. A random interstellar object would come from any direction, at any angle. But 3I/Atlas seemed to be flying along the same plane as Earth, Mars, Venus, and Jupiter, as if it had been aimed. And then there were the jets. Active comets often eject plumes of gas from specific spots on their surface, creating visible jets that can alter the comet's trajectory through a rocket effect. 3I/Atlas had multiple jets, but one of them was different. It pointed directly at the sun. Always. As the comet rotated, as it moved through space, this jet remained locked on the sun like a searchlight tracking a target. The odds of that happening naturally? Close to zero. Enter Avi Loeb, chair of Harvard's astronomy department for 9 years, author of hundreds of peer-reviewed papers, founder of the Galileo Project, an initiative to search for evidence of extraterrestrial technology, and, to many of his colleagues, a controversial figure who has pushed the boundaries of acceptable scientific speculation too far. Loeb made headlines in 2018 when he suggested that Oumuamua, the first interstellar visitor, might be a light sail, a thin reflective sheet propelled by starlight, possibly of artificial origin. The backlash was swift. Most astronomers dismissed the idea as sensationalism, but Loeb didn't back down. He argued that dismissing the possibility without investigation was unscientific, that the refusal to consider extraordinary explanations, even unlikely ones, was a failure of imagination. When 3I/Atlas was discovered, Loeb was ready. Within weeks, he and his colleagues published a paper titled, "Is the Interstellar Object 3I/Atlas Alien Technology?" The paper was a thought experiment, a rigorous analysis of what would be required if the object were an artificial spacecraft. How much thrust would it need to intercept Earth, or Mars, or Jupiter? The calculations showed that relatively modest propulsion, comparable to an intercontinental ballistic missile, would be sufficient to deploy smaller probes to any planet in the inner solar system. The paper didn't claim the object was alien. It simply demonstrated that if it were, the physics would work. But the media ran with it. Headlines screamed about alien motherships and potential threats. Loeb appeared on news programs, carefully stating that he believed the object was most likely natural, but that the anomalies warranted serious investigation. He introduced the scale, 0 to 10, ranking the likelihood of alien technology. He placed 3I/Atlas at a 4. Unlikely, but not impossible, enough to justify vigilance. His colleagues were furious. They accused him of fear-mongering, of undermining public trust in science, of chasing fame. But Loeb had a response. When the implications are existential, he argued, even a low-probability event demands attention. He compared it to intelligence failures, September 11th and October 7th, where unlikely scenarios were dismissed until they became catastrophic reality. He invoked Pascal's wager. If there's even a small chance that 3I/Atlas is a probe, the cost of ignoring it could be incalculable. Better to investigate and be wrong than to dismiss it and miss the most important discovery in human history. And then, in November, something happened that silenced some of his critics. Radio telescopes detected a signal from 3I/Atlas, a structured burst at 1420 MHz, a frequency known as the hydrogen line, considered one of the most likely channels for interstellar communication, because it's naturally emitted by hydrogen throughout the universe. The signal was brief, repeating, and nobody could immediately explain it. The South African Meerkat Telescope, one of the most sensitive radio observatories in the world, conducted follow-up observations. Their conclusion? The signal was natural. Radio emissions from the comet's coma, ionized gas interacting with solar radiation. Not a message, not technology, just physics. But for a brief moment, the world held its breath. NASA and the European Space Agency mobilized every available asset. The Hubble Space Telescope captured high-resolution images, revealing the comet's structure in unprecedented detail. The James Webb Space Telescope used its infrared instruments to analyze the comet's composition, detecting water vapor, carbon dioxide, and organic molecules. The Parker Solar Probe, on its daring mission to study the sun, captured images as 3I/Atlas passed through the inner solar system. The Psyche spacecraft, on its way to explore a metal asteroid, paused to observe the visitor. The Mars rovers Perseverance and Curiosity pointed their camera skyward. Even the Europa Clipper, heading to Jupiter's icy moon, turned its instruments toward the comet. Every observation added data, and every piece of data raised new questions. The comet's non-gravitational acceleration, the tiny push caused by outgassing, matched natural comets almost perfectly. That should have settled the debate, but the alignment of that acceleration with the sun was statistically improbable. The comet's brightness varied in ways that suggested a complex, irregular shape, possibly with multiple lobes or fragments. Some amateur astronomers claim to have detected smaller objects traveling alongside 3I/Atlas, like escorts or probes. Official analysis found no such objects, attributing the observations to image artifacts and wishful thinking. As the comet passed Earth on December 19th, coming within 170 million miles, close enough to be studied but far enough to pose no danger, the debate reached a fever pitch. Loeb appeared on news programs warning that if the object were hostile, humanity would be helpless. Other scientists accused him of irresponsibility. The truth, as always, lay buried in the data. And the data, frustratingly, was ambiguous. So what is 3I/Atlas? The scientific consensus, the position held by the vast majority of astronomers, is clear. It's a comet, an icy body ejected from another star system billions of years ago, drifting through the galaxy until it happened to pass through our neighborhood. The anomalies, the green glow, the sun-locked jet, the trajectory alignment all have natural explanations. Complex, yes. Unlikely, perhaps, but natural. The outgassing explains the non-gravitational acceleration. The rotation axis alignment is rare but not impossible. The ecliptic alignment is coincidence, made more striking by selection bias. We notice the objects that pass us near us, and those are naturally more likely to be in the ecliptic plane. The green color is diatomic carbon, a normal cometary emission. The sun-locked jet is a result of uneven heating and rotation, a phenomenon seen in other comets. Every anomaly, when examined closely, has a plausible explanation. But Loeb and a small group of scientists aren't convinced. They point out that plausible doesn't mean proven, that stacking multiple low-probability events creates a cumulative improbability that can't be ignored, that dismissing the artificial hypothesis without thorough investigation is premature. They argue for agnosticism. We don't know. We should admit we don't know, and we should keep watching. As 3I/Atlas accelerates away from the Sun, moving back into the darkness beyond Pluto's orbit, the window for observation is closing. Within months, it will be too faint for even the most powerful telescopes. Within years, it will be gone, lost to interstellar space, carrying its secrets with it. We will never get another chance to study this object up close. The data we have is all we'll ever have. And so the question remains unanswered. Natural or artificial? Comet or probe? The evidence leans heavily toward natural, but it doesn't eliminate the alternative. And in science, when the stakes are this high, uncertainty is terrifying. What does this mean for us? Whether 3I/Atlas is a comet or something else, its arrival has forced humanity to confront an uncomfortable truth. We are not as isolated as we thought. Interstellar objects pass through our solar system regularly. We've only detected 3 because our telescopes are limited, but estimates suggest that dozens, perhaps hundreds, pass through every year, invisible, unnoticed. Most are small, some are large, and a few, like 3I/Atlas, are extraordinary. The next generation of telescopes will change everything. The Vera Rubin Observatory, coming online soon, will scan the entire visible sky every few nights, detecting faint moving objects that current telescopes miss. Scientists estimate it could find up to 50 interstellar visitors per year, 50 objects like 3I/Atlas, each one a messenger from another star, each one carrying information about distant solar systems, their chemistry, their history, their potential for life. And if even one of those objects turns out to be artificial, if we detect a probe, a signal, a piece of technology that cannot be explained by natural processes, then everything changes. We will know, for certain, that we are not alone, that intelligence exists beyond Earth, that someone, somewhere, has reached the stars before us. But there's a darker possibility. One that Loeb has mentioned in interviews that most scientists refuse to discuss publicly. What if 3I/Atlas is a probe and its purpose is surveillance? What if an alien civilization sent it to study us, to gather information, to assess whether we're a threat or an opportunity? The dark forest hypothesis, a solution to the Fermi paradox, suggests that the universe is silent because civilizations hide, fearing contact with potentially hostile species. If that's true, then revealing ourselves might be dangerous, and an interstellar probe, if it exists, would be the equivalent of a scout, reporting back, preparing the way for what comes next. Loeb, in a now infamous quote, warned that encountering alien technology is like going on a blind date with interstellar proportions. You never know if you're meeting a friend or a serial killer. It's a stark, dramatic statement, one that most scientists find distasteful, but it captures the essence of the uncertainty. We don't know. We can't know. And the consequences of being wrong could be catastrophic. As 3I/Atlas fades into the distance, racing toward the constellation Pegasus at speeds no human spacecraft could match, we're left with questions. Haunting, unanswerable questions. Did we just witness a natural phenomenon? A cosmic coincidence? A beautiful reminder of how vast and strange the universe is? Or did we miss something? Did we overlook the evidence? Dismiss the warnings? Fail to see what was right in front of us? The truth is, we may never know, and that's the most unsettling part. The object is gone. The data is incomplete. The debate will rage for years, decades, But without new evidence, it will never be resolved. 3I/Atlas will join Oumuamua in the pantheon of cosmic mysteries, objects that defy easy explanation, that tantalize us with possibilities we can't prove. But here's what we do know. We are living in an era where interstellar visitors are no longer theoretical. They're real, they're here, and we're finally capable of detecting them. The universe is not empty. It's full of wanderers, ancient objects ejected from distant stars, drifting through the void, occasionally passing through our solar system like ships in the night. And every one of them is a message, a bottle thrown into the cosmic ocean, a reminder that we are part of something vast and incomprehensible. Whether 3I/Atlas was a comet or a probe, it has given us a gift. It has forced us to ask questions we've avoided, to confront the reality that contact with alien intelligence, if it happens, might not be the joyful, enlightening moment we've imagined. It might be confusing, ambiguous, frightening, and we need to be ready for that. The visitor has passed, but others are coming, and next time we'll be watching. Next time we'll be ready, or at least we'll try to be, because in the end, that's all we can do. Watch the skies, gather the data, and hope that when the answer finally comes, we're brave enough to accept it.